Thanks for coming. I'm surprised that after 5 p.m. there are still people here. So when I saw the agenda that I have a session at 5 p.m., I said, wow. I was not surprised because at 5 p.m. sharp there was no one in the room, so I said, okay. Worst case, I go home early. So my name is Jacint, I'm SC for NetApp, if you haven't heard that yet. I will talk about NetApp E-Series. So NetApp E-Series is, we had a lot of time to figure out what to do with this stuff, because so we acquired, so NetApp E-Series is an acquisition. So we acquired Ngineo from LSI, I think 2010-ish. And so if you look at the box, it's for pretty much all the NetApp engineers, it's hard to figure out what this thing does. So pretty much all the NetApp engineers are familiar with unified storage because this is what we do for a very long time. And this thing is different. This is block storage. So this is a pure LAN-based block storage. It does fiber channel, ISCSI, and block protocols, but it's completely far away what we have done for a very long time. And even product management, it took a lot of time to figure out what to do with this thing. So the original the product has been designed for OEM. So LSI did not sell this thing directly at all. You may know the storage system from IBM. It was IBM DS3, 4, 5,000 systems. You may know it from Dell PowerVault. Oracle did sell it under the Sun flag and then under the Oracle flag, SGI. There's a lot of OEMs, and NetApp said for a long time that okay, we're not going to touch the OEM business. We just will leave it as OEM. But sooner or later, the OEM partners disappeared, and we had a storage platform. So what to do if there's no one to sell? And first we created bundles. So first we said that, okay, we are not going to sell this box alone. We will sell this box only with bundles. So we created Hadoop, we created media and video surveillance kind of bundles, storage grid, and so on. And we only sold with bundles. So guess what? We didn't get a lot of sale. So we tried to figure out what to do with that, and roughly 2 years ago, we started to sell it as pure the storage system itself. So today E-Series is one of our most successful products. So I would say after FAS, this is what we sell the most. And there are places where E-Series is even more successful than FAS. FAS is awesome. I came to NetApp work because I am a FAS fan. So for me, it's especially difficult sometimes to talk about E-Series because I truly believe, for me, FAS is the perfect storage platform, and this thing is completely different. I touched my first system back in the Sun days, roughly 10 years ago, E-Series. And it is reliable, it's extremely stable, and extremely easy to configure. So I usually call it Easy Series, the E-Series. So if you had any of my sessions, probably you saw this. NetApp built a wide portfolio in the last couple of years. So now we have multiple storage platforms. We have storage platforms shipping. We have storage platforms coming in the future. We have a lot of software products and so on. I would not take a lot of this. So through the OEM ship and also our own sales, we have nearly 1 million systems sold and shipped out of this thing. And the most important thing about SAN-based systems is that we have a huge interop matrix. Interop matrix matters. So as original NetApp knows, NetApp started to ship SAN systems roughly 14 years ago. And the first SAN version of SAN was the interop matrix was fitting in half of an A4 paper. because creating SAN-based systems is extremely expensive. You need, for qualifying, you need to buy servers, you need to buy HBAs, you need to buy fiber channel switches. You need to set up a lot of scenario which is time-based, and then you create an interop matrix, and then a customer shows up who has a completely different thing, and you need to start verifying from the beginning. So this is easy because with E-Series, pretty much everything is supported. So we don't have any fear. You may have any kind of server, any kind of operating system. It's pretty much supported. With E-Series, currently we have 5 different systems. 5 different systems are I would say 5 different controllers. So the most important thing you need to know about E-Series, that with E-Series we don't target the enterprise line. So E-Series is an entry-level and mid-range storage. So these are the 2 lines what we actually sell. We have one controller which is an entry-level controller. This is the E2700. We have 2 types of that based on the cache memory. And we have 4 different type of mid-range ones. So that actually means 2 different controllers, the 5500 and the EF550. These are the ones which are on the market for a year or a year and a half now, and they are going away. And the new ones are the E5600 and the all-flash version, the EF560. So these are the new ones. We released these models in the end of January, and these are taking over the 5500 and the EF550. The most important thing to know about E-Series is really, it is extremely easy. So once one of our disties asked me that, okay, I have a couple of partners, can you please do us an installation workshop about E-Series? It would be a half day. And I told them it's not possible because you can install this system in 30 minutes, so what the hell, I will talk about half a day. And somehow I figured out, but it's literally, so if you have DHCP in your network, you will finish the installation in 20 minutes. If you don't, probably you will take like 25. But it's really, this is the time you need to install this system. It's really, really easy. We support 3 types of configurations with E-Series. We support pure disk-based systems. We support hybrid. So hybrid is when you have a combination of flash and spinning drives. And we support all flash systems. We usually don't sell the 2700, so the entry-level controller with all flash, because if you look at the pricing of the box, then the pricing is pretty much defined by the number of SSDs. So if you buy an all-flash system, the price is pretty much dictated by the number of the SSDs, and there is not a huge difference between an all-flash E2700 and an E55, so an EF550 or 560, and that's why we decided that, okay, we are going to sell the all-flash versions only with a bigger controller. It doesn't stop you to force the partner to create you a quotation, but probably it will not be affordable. We have, so it's the Lego platform. This is how I call it. I remember back in the IBM days, so I had a meeting with someone today. They showed me an E-Series quotation, what they get from the partner, and the quotation looks like horrible. So we quote these systems in every single part. So you will see controllers and I/O modules and chassis and number of drives. It looks horrible. And in the IBM days, even the shipment was like that. So if you ordered a storage system with like 4 shelves, it was like 80 boxes. You got every single hard drive in different boxes and the controllers, and it took like, that's why I call it Lego platform. It took like half a day to put together the system. Like if you buy something with IKEA and you bring it home and you need to assemble, it was like that. We don't ship like that anymore, but the quotation still looks like that. So we have 3 types of chassis. So obviously the standard 2-unit chassis are nothing special. So we have a 2-unit chassis with 24 drives, So these are the small form factor drives. It's typically SAS or SSDs. And there are the large form factor drives, which are the nearline SAS drives. And this is also 2-unit chassis and fits 12 drives. So there's no magic, pretty much the same what everyone else sells. However, we have a 4-unit chassis, which is kind of a different thing than the standard ones. So in the 4-unit chassis, you can store 60 drives. So in the 4-unit chassis, we have 5 drawers, and in each and every drawer, you have 12 drives. So basically, the main reason is the creating something which is very depth. So you can if you look at this chassis, you can have 10 of these in a single rack. So that means you can have 600 drives in a single rack, and still maintains the serviceability. So this is not the only this kind of depth shelf on the market, but usually these kind of shelves you need to pull out the whole thing to make the service. And these things are very heavy. So if you pull out something, it is very easy. So first of all, you need maybe 2 of the guy who pull out the system to replace something on the top. And also it's not very easy to handle. So what the engineering made the decision that, okay, they want to create something which is very deep. So you can put a lot of hard drives in it, but it maintains the serviceability of the standard shelves. So you get these drawers, and you can pull out the drawer, and each and every drawer have 12 drives on it. And basically, you pull out the drawer, the spinning discs are spinning on it, and you can lift. There is a handle to lift. You lift the handle, take out the drive, pull in the new one, or pull in the replacement one, and push it back. It's really, really cool. I saw it in data centers, and it's nice. And obviously, if you go for a mixed configuration, when you need a small form factor and big form factor drives, in 4-unit you would get 24. With this one, in 4-unit you will get 60 drives. It's a little bit more expensive, but if you want expandability in the future, it's probably a better idea to start with this chassis. We use the same chassis for controllers and for shelves. So if you look at the system from the front, there's no difference. The controller and the shelf look like exactly the same. So if you go behind the system, you will be able to figure out if it's actually a controller, so if it's a storage system, or just a shelf for an additional storage system. And the numbering are basically very easy. So the first 2 numbers will define which controller you are working with, and the second 2 numbers will define that which is the chassis you are working with. So if you take the 2700 controller with the 60 drive chassis, it's going to be the 2760. So it's very, very, very easy. From the all-flash platform, we don't have the 60 drive chassis. So this is a pure SAN-based system, and with pretty much everybody out there, we working with standard RAID levels. So what we usually don't do with FAS, we have RAIDs, so RAID 1, RAID 3, RAID 4, RAID 5, 6, and the likes. So this is the standard. What is interesting here, and this is what I'm going to take most of the time of the presentation, we have a thing which is called dynamic disk pool, which has been designed to fix the issue what you may have with standard RAID levels. The naming convention here is that we call the LANs volumes. So when you create RAID, the RAID will be a volume group, and on top of the volume group, each and every individual LANs are going to be the volumes. So you will map the volumes to the host, and so on. With dynamic disk pool, we call the disk pool as a disk pool, and on top of the disk pool, we are going to have LANs, which are also called volumes. And we have features. So even though the system is very easy, we still offer features what you want to have in a standard storage system. So we have, so number one, the most important one here is the dynamic disk pool, but we offer SSD hybrid cache. We offer snapshot copies. I don't call it enhanced snapshot copies because I think the snapshot is de facto is what we have in FAS. So this thing is different, I will emphasize that. We have team provisioning and we have replication, and obviously we have encryption, so built-in encryption. So let's look at the hardware. This is how a controller look like. In fact, this is the 2700 controller, so this is the entry-level controller. So we sell this controller with two type of configuration. We sell it with 4 gigs of RAM, so 4 gigs of cache, and 8 gigs of storage cache. The important thing with the entry-level controller that even without an expansion, so the reason it look like this, that there is no expansion card in this controller. So the entry-level controller is the only controller, what you can use without an expansion card at all. So if you take the basic controller without any expansions, you can still use for host connection. So there are 2 SAS host connections. So that means that if you have 1 or 2 servers, you can take a basic E-series configuration without any additional card, and you can direct connect the E-series storage to the servers. If that's not enough, we have 5 different additional cards which you can use, only one of them. So the E-series only have one single expansion port, and these 5 different cards are mainly 3 different cards in reality. So the first 2 are going to be the ones are mainly used. So these are cards which can do fiber channel or it can do iSCSI. The interesting thing about these cards that these cards can do either fiber channel or iSCSI, not in the same time, but you can decide which one to use. And we are using SFPs them, and even the SFP can do iSCSI or fiber channel. You can select which one you want to use. The second type of card, we have SAS. So if you say that I'm going to use basic SAS because I don't want to buy switches, I have like 6 servers and I'm going to be okay with direct attached storage, you can buy the 2-port or the 4-port SAS connection. So altogether you have 6 SAS ports per controller, so that's going to be enough for 6 servers in a multipath HA configuration. And we have a third type of card, which is a standard RG45, so it's a category 6 Ethernet card. It can do 1 gig or 10 gig Ethernet, and it will auto-negotiate. The bigger brother, let's say like this, so the E5600 controller is similar to the small one. The only difference is that you cannot have any host connection without a host interface card. So in the mid-range controller, you have to have a host interface card if you want to attach to a host. And make no surprise, we are using the exact same cards with the mid-range systems. The only difference is that we don't sell the 2-port ones. So from fiber channel iSCSI ports, you are going to have 4 per controllers. From the SAS, you are going to have 4 per controllers. And there's an additional one which can do 6 gigabits, so it will be a little bit slower. But what is more important here, we also have an InfiniBand. So if you want to run InfiniBand network, you can use InfiniBand with E-series. I will be honest with that. I haven't seen any E-series sold with InfiniBand. People just don't use it. InfiniBand is not cheap. This is not the weakest link of your data center, so you can say that, okay, I want 55 gigabits per sec, but I tell you what, this is not this is not where you can tune your storage system. It's mainly done on the controller level or in the backend. There are cases, there are corner cases when InfiniBand can be faster, but I don't see those a lot. So let's look at the storage configuration. So I said we have standard RAIDs. With standard RAIDs, I mean RAID 1s, RAID 5, RAID 6s. And with standard RAID, we are using hard drives. We configure them in volume groups. So these are the RAID groups. And on top of the volume groups, we will create LANs, which are called volumes. We have the standard ones. These are the ones mostly used by people. So usually I'm coming from the fast world, and I tell people, because I grew up with telling people don't use RAID 5, so I simply tell people that, okay, don't use RAID 1, RAID 0, that's a bad idea. Don't use RAID 1, that's a little bit better, but still a bad idea. The reason for that is that if you lose your second drive, which is not in a good way, so not in the way you would like to fail 2 drives, you're gonna lose your data. And don't use RAID 5, because that's a bad idea. RAID 5 is the same. If you have a disk failure, if you start to rebuild and you get another disk failure while you have the rebuild, you're gonna lose your data. This is how it works. And the issue with that is not which is not the easy part. So it's not happening like you are going to have 2 drive failures, because that's not happening. I don't see any customer having 2 drive failures in the same time. So it's not like you got a call, I have a drive failure, and then you got a call, I have a drive failure. It's not happening like that. What usually happens is that if you have a drive failure, you start rebuild. And when you have rebuild, so normally, if you don't have a drive failure, how you use your drive? Maybe you have 50% of the capacity utilized. If you have 50% of the capacity utilized, you are using 50% of the drives. If you use 50% of the drives, if you have a bad block, who cares? The disk will have another block, and it just replacing the blocks. If you have a rebuilding, that you will read each and every drive in your configuration from the beginning till the end. And if you have an uncorrectable read error, when you do the rebuild, you're going to have a second drive failure, and eventually you will lose data. So this is how RAID 5 works. So I usually tell people use RAID 6. RAID 6 is a semi-good idea, let's say like this. RAID 6 is good because it is going to save your life when you have a second drive failure, but it's not the fastest thing on earth. So this is the main reason why not to use RAID 6. Everything was wonderful when we had 300 gig drives, right? But we have big drives now. We have now, I think the biggest what we sell is 6 terabytes. So if you look at this picture, a 3 terabyte drive, reconstruction, if you use RAID 6, is going to take 3 days. And the main issue, and the even bigger issue, it's actually 4 days. The even bigger issue is that most of the time when you have the reconstruction, it's affecting your performance. So what the picture is trying to show that these are the drive size. So if you have the 2 terabytes, it's 2.5 days. If you have the 3 terabytes, it's 4 days. We eventually asked the product management what is the rebuild time for 6 terabyte drives, and you don't want to know the answer. It's just too long. The main issue is that what the line trying to show is what is the performance impact of the drive rebuild. Especially with SATA drives, if you are rebuilding drives, it's going to hurt your performance. This is how it is. So what DDP is doing, and sorry for the marketing, this is a horrible one. So what DDP is doing is trying to decrease the impact of the rebuild. So with DDP, the rebuild will be a lot shorter, and the performance impact of the rebuild will be a lot less. So what this one is trying to say is that this is the curve you have with RAID 6. So it's going to take a lot of time, and the business impact part is almost the almost 100% of the process. If you have DDP, you still stay in the optimal performance range, and in the rebuild part is a lot slower. So basically, if I zoom in that part, so the 4-day can decrease with DDP to 1.5 hour, and the performance impact, actually the performance impact will be 1.5 hour, and the rebuild of the drive will be roughly around the day. Still, the rebuild will take a day, but the performance impact part of the rebuild will be 1.5 hours. So that's a lot difference. So basically, that means that the application performance will be slow for 90 minutes, 96 minutes instead of 4 days. So let's see how DDP works. Actually, the guys who invented the DDP part within Ngineo, they thought it's a so good idea that they left Ngineo and they created a storage startup just based on this idea that they created this DDP concept. So in DDP, we don't use disk-based strategy. So if you look at RAIDs, every single RAID level is based on disk levels, right? So if you have mirror, you have one disk and you have a mirror. If you have RAID 5, you have data drives and you have parity. If you have RAID 6, you have data drives and you have parity. In DDP, you are not using drives, you are not allocating drives, you are allocating capacity. So with DDP, you are allocating all of your drives into a pool, and the pool will handle all of your drives. And for example, you are not using spare disks. So there's no spare disk in a DDP environment. You have spare capacity. So when you write in DDP from a writing perspective, it will work similarly as RAID 6. The only difference is that we are not writing into individual drive. We will write to a random set of 10 drives. So DDP works like an 8+2 RAID 6, sorry, but it will always decide for different 10 drives in the DDP set. So what I have example in this picture is a 24 drives pool. And in this 24 drives pool, with every single stripe write, I write to different 10 drives. When you create the DDP, you will decide what is the minimum disk failure, what you can or you want to tolerate. So the minimum size of the DDP is 11 drives. With 11 drives, the system will tell you that, okay, 1 is the minimum, 1 is the best practice to have as a spare capacity. So that means if you have a failure, you can rebuild one drive. And then if you have another failure, you can still tolerate. And if you have a third failure, you can still tolerate. But if you have a fourth failure, you're gone. If you create a 24 drive pool, the 24 drive pool will have as a default 2 drive capacity as a spare. So that means you right click on the DDP configuration and it will tell you that the spare drive capacity is 2 drive worth of data. So it will tell you that, okay, if you have 24 drives, you have the capacity of 22, okay? So you can fill up the data with the 80% of 22 drive worth of data. So if you fill up that capacity, that means that you can have one drive, you rebuild. You can fill another drive, you rebuild. You can fill another drive, you start to worry. You can fill the fourth drive, you are worrying, really. And when you fill the fifth one, you're gone. If you have less capacity, that's a different story. So how it works? If I fail a drive, it doesn't mean that I have something degraded or less available RAID set. I just have a 23 drive pool instead of the 24 drive pool. And what eventually happens is that it will start to go from one block to the other and to the other, and basically it will look at the DDP set and will figure out that, okay, I have this orange block here, I will try to write this orange block somewhere else, and probably in a drive which doesn't have any other orange block, so it doesn't have other block from the same exact stripe. And it will go basically stripe set by stripe set by stripe set. But the interesting thing here, and that's why the rebuilding is a lot faster, as it's going through, it will use all the 24 drive in the RAID set or in the DDP set. So eventually, compared to RAID, the way you are rebuilding in RAID, if you have a drive failure, that you try to regenerate one single drive worth of data. Right? So if you have a drive failure, you take all the drives and you try to write all the data sets and all the parities on that one single drive. If you have a drive failure in DDP, you try to evacuate the data from that, but in this example, 23 drive in the configuration will work to rebuild your data set. And that's an important difference, because that means that 23 drive of performance will be used to regenerate your data. Once you're finished, so once you rebuild the data set, you can replace the drive, but replacing the drive is not really replacing the drive. You will add a drive to the configuration, so you will increase the size of the DDP from 23 to 24, so you again have a 24 drive DDP. And the system will figure out, okay, you added one more drive into your DDP set, so it will try to put roughly the same amount of data into the new drive what you have on all of the others, so it will balance your DDP set. This is how it works. So this is how you pull out drive, and this is how we insert back drive. We have a demo on the YouTube. Two funny guys are playing with DDP and RAID set. They are using EF, so an all-flash system, and they start to pull out drives. So obviously after the third drive taken off, the RAID 6 is gone, and the RAID DDP, not RAID, sorry, DDP is still alive, and they monitor and they generate some traffic with iometer and so on and so on. So it's very interesting. They have this, please don't try this at home kind of behavior with this test. You can change a lot of things in DDP. So you can change the capacity you willing to invest for rebuilds. So for example, I said with the 24, the default is 2 drive capacity worth of spare. But if you're more paranoid, you can say that, okay, I'm willing to invest 4 drive worth of capacity. Or you can say that, okay, I go down to the minimum, which is 1. The other thing you can set is, you can set priorities, rebuild priorities. And there are 2 types of rebuild priority. So if you have, let's say, 2 drive failure, and let's pick 2 good ones. So let's say you fail drive 2, and in the same time you fail drive 14. The issue with losing drive 2 and drive 14 is that in both drive 2 and drive 14 you have magenta or purple or whatever this color. I would call it magenta. Let's call it T-Mobile color. So you lost 2 of the T-Mobiles within the same time. So that means if you look at the pieces work like pretty much like RAID 6, so you start to worry, right? And DDP start to worry as well, and it will say that, okay, now I have a critical issue, and I need to rebuild the critical issue. So first, it will do that, okay, I lost 2 drives. Let's check which of the slices I have on these 2 drives which exist on both of the 2 drives, and that will be the critical reconstruction. And after it finished those pieces which was on both the two drives, it will start the normal reconstruction. So if you go to the DDP configuration, you can check the priority of the critical rebuild and the standard normal rebuild. DDP is funny. The minimum DDP size is 11 drives. So usually when we sell systems with 12 drives, 11, 12 drives, I usually tell people just create one single DDP, and one single DDP will be enough because the limit of the DDP is the platform limit. So if you have an entry-level system, the platform limit will be 192 drives. If you have a mid-range, the DDP limit will be the platform limit, which is almost 400 drives. You can increase the size of the DDP with 1 drive or 12 drives, so you can add drives. So if you are lucky enough to operate bigger storage systems and you add like 24 or 48 drives into the DDP, you can set 12 drives in once and add into the DDP set. And with DDP, we do have LAN limit. So normally with RAID, we don't have LAN limit. So normally with RAID sets like RAID 10s and RAID 5s, the LAN limit is the size of the RAID. But with DDP, as you can create almost infinite size of the pool, so imagine 384 6 terabyte drives, that's a load of capacity. You cannot create one single LAN of that size. 64 terabytes will be the limit. And there are actual people who wants to create LANs like this. Once I had a customer who said that I want to create a 100 terabyte LAN because I want to use that for a single pool for my backups. And so number one obvious question, which is the operating system which can handle a 100 terabyte LAN in once? There's not a lot of those. But even though you can, I don't think it's a good idea to create one single LAN, 100 terabytes, and create a file system on that. That can create a lot of issues. So there are a lot of things. There's a very nice comparison table that, okay, what is good with RAID 6, what is good with DDP. We build a decision tree, if this, then that, choose this and that. I have an extremely simplified version of what to choose, RAID 6 or DDP. We sell mainly the entry-level systems with E-series, and people usually buy it for 2 reasons. One reason usually is that, okay, I have 2, 4, 5, 10, whatever servers, I need a central storage, I only need 10, E-series will work fine for me, and I will put my, let's say, virtualization, messaging, whatever on that, and that's a random type of workload. In random, DDP is better. The other option people usually buy E-series is because I'm building a backup system, I have ABC backup application, I need a pool behind it, I need sequential performance, go with RAID 6, it's that easy. So if you need sequential performance, go with RAID 6. If you have mix of sequential, random, or just random, go with DDP. With E-series, we have an awesome performance monitor built into the system. It has default values, and you can create your own schemas, and you can create your own charts. It's really, really, really good. It's extremely easy to create your own charts, and it's very, very, very good to see. I would love to see something like this in our FAS systems. Licensing. So what is the licensing policy with E-series? The licensing policy with E-series, we give all the licenses free of charge with the system except for one. The one license which is considered as a premium feature is a drive encryption license. So if you work for a paranoid employer who says that, okay, I need drive encryption, that this is the license you need to buy for that, and there's actually different type of drives. So we sell standard drives and we sell encrypting drives. So in the encrypting drives we have an encryption chip, and then the internal drive encryption can work with that. 99% or 99.99% of the cases we sell without encryption because people usually don't use that. So outside of drive encryption, all the features are included. Which is a funny thing because with IBM and Dell, they sold the licenses in different packs. Even they had a turbo license. So what a turbo license did is you got your system without the turbo license, it was limited in IOPS, and if you needed more performance, you bought the turbo license, and it was unlocking the turbo feature, which is nice. So you get the turbo license and all of the licenses with the system for free. Closing the presentation, we have application plugins. So we have currently 3 types of application plugins. We have a vSphere, we have a Microsoft, and an Oracle one. The vSphere is basically a vCenter plugin, and we have an SRM, so a site recovery manager adapter. So obviously, as I said, all the features are included. So the remote replication is included as well. So if you buy 2 systems and you want to have VMware as RM between them, that's also provided with the system. We have a WhatsApp plugin. It's not really used by a lot of people, but you can provision, you can manage, you can monitor directly from vCenter. We have a Microsoft plugin. Actually, it's 2 different Microsoft plugins. It's a SQL plugin. So from the SQL Studio, you can monitor the storage system and you can create objects. And also, we have a SCOM, System Center Operations Manager plugin. So if you have a SCOM infrastructure, you can monitor the E-Series storage system through the SCOM. And the third one is an Oracle Enterprise Manager plugin. So if you run Oracle and if you have the Enterprise Manager, you can see the storage metrics and the storage performance directly from Oracle. So this is actually, I wanted to talk about E-Series. Most of the times I used for DDP for a good reason, because it's really not known by people most of the time, and DDP is actually is a good technology. The licensing, I think, is important, so there is no licensing constraints with E-Series. And this is not a bad SAN system. So what usually I say that people buy storage in 2 different ways. So there are people who are willing to invest time to save money, and there are people who are willing to invest money to save time. So this system is for people who are willing to invest time, because there are not so many features like with FAS, but it's still reliable. So we measured 6 nines availability with E-Series. It is very, very fast. So it's a pure controller with CPU with a specified tuned firmware running on it, and it's extremely easy to configure, and it will be really, really fast. Thank you for your time, and I really, really appreciate that you came to the last session. Honestly, I thought that no one will show up, so thank you for your time. I hope you enjoyed the conference. It was a good time for me, and I will come next year as well. Thank you. Safe travel home.